Part 2 of May June 2015, Paper 12, Physics. Question 11. Trolley X, moving along a horizontal frictionless track, collides with a stationary trolley Y. The two trolleys become attached and move off together. Which statement about this interaction is correct? So trolley X is moving along a frictionless track, colliding with a stationary trolley Y, and after the collision, they move off together. We have to choose among this option which option is correct. This is an example of inelastic collision. Inelastic collision means momentum is conserved, which means trolley X momentum plus there is no momentum of trolley Y because it is stationary is equal to the momentum, the total momentum after collision. Now the trolley Y is moving, so now it has gained momentum. So it should gain from trolley X. So as you can see, kinetic energy is not conserved in inelastic collision. So option A, sum of the kinetic energy of trolley X is changed to momentum in the collision, which is incorrect. Option B, sum of the momentum of trolley X is changed to kinetic energy in the collision. Again, that's incorrect. Trolley X loses some of its momentum as heat in the collision, which is wrong. Trolley X loses some of its momentum to trolley Y to make trolley Y gain its momentum. So this is incorrect. Option B, trolley X shares its momentum with trolley Y, which is correct, but some kinetic energy is lost. Kinetic energy is lost because it is an inelastic collision. Therefore, the answer is option B. Question 12. An astronaut throws a stone with horizontal velocity near the moon's surface. Which row describes the horizontal and vertical forces acting on the stone after release? As you know, the stone is thrown near the moon's surface. There is no air resistance near the moon. So what happened? The horizontal velocity is not going to be affected by any other conditions. Therefore, the horizontal velocity is going to remain constant, which means the acceleration is 0. If acceleration is 0, the horizontal force is going to be 0. According to Newton's second law, force is equal to mass into acceleration. So if horizontal acceleration is 0, horizontal force will be 0. That's what they're saying. The stone is thrown near the moon's surface. In space, there is no air resistance. Thus, the horizontal velocity is not affected. Therefore, the horizontal force is 0. In case of vertical force, the moon has its own gravity and no air resistance. Therefore, the vertical force acting on the stone is constant. Why is it constant? Because the vertical acceleration is going to be the gravity, due to the gravity of the moon. So the acceleration, when it remains constant, the force remains constant. So from this option, your horizontal force should be 0. So it's either C or D, but your vertical force should be constant. Therefore, your option is C. Question 13. Newton's third law of motion is often summarized as every action has an equal and opposite reaction. A book rests on a table. If the weight of the book is the action force, what is the reaction force? So weight of the book is the action force. Weight of the book means the pull of the earth on the book. The pull of the earth on the book. As you can see, Newton's third law, if an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. So now the earth is pulling the book, so the book should pull on the earth. So the pull of the book on the earth is the answer. As you can see, that option is A itself. The option is A. Question 14. The ladder is positioned on icy ground and it is leaned against a rough wall. At the instant of release, it begins to slide. So there is a ladder. You can see in the option there is a ladder. It's positioned on a frictionless ground. So this ground is frictionless. Which diagram shows the direction of the force P, W, and R acting on the ladder as it slides? The ground is frictionless. That means it's a smooth. There is no friction. The wall is rough. It has a friction. So W is going to be weight, which will act always vertically downwards. So as you can see in the diagram, all options have the same diagram where W, that the weight acts vertically downwards. R is the normal reaction on weight acts vertically upward because the ground is frictionless. Since the ground is frictionless, we do not consider the resultant of the force exerted by the ground. We only have to consider our R to be vertically upwards. As you can see, that is in option A and B. So option C and D is not the answer. So either A or B is the answer. P. What is P? So when ladder slides down, it's about to slip. When ladder is sliding down, since the wall is rough, the friction will move upwards. So you can see here, when the ladder slides down, the friction on the wall acts vertically upwards. So when it's sliding down, friction is moving in the upward direction. Also, ladder exerts a force on the left of the wall. So that ladder is leaning here, so the ladder exerts a force towards the left on the wall. According to Newton's third law, the wall will exert an equal and opposite force on the ladder. So that is the wall will exert an equal and opposite force on the ladder to the right. P is the resultant force of these two forces. So when ladder is sliding down, the friction acts upwards. There is a push. There is a force by the ladder on the wall. According to Newton's law, the wall also will give a push on the ladder. So that is this one, push on the wall. So the resultant of friction and push of the wall is your P. So P is in this direction. So as you can see in this diagram, they did not consider the resultant of the push and the friction. Therefore, the answer is option B. Question 15. A uniform solid block has weight 500 Newton, width 0.4 meter and height 0.6 meter. The block rests on the edge of a step of depth 0.8 meter as shown. The block is knocked over the edge of the step and rotates through 90 degrees before coming to rest with the 0.6 meter edge horizontal. What is the change of gravitational potential energy of the block? So now the block falls from a step and as you can see 0.4 meter is the base, but when it falls 0.6 meter, the edge 0.6 meter is the base. In this case, you have to calculate the center of gravity. Since the solid block is uniform, the center of gravity is going to be exactly at the middle. So in this diagram, you can see the center of mass is kept 0.3 meter from the base. And when it falls, it's falling with the height 0.4 remains on the side. So the center of gravity is going to be 0.2. So the initial height is going to be 0.8 plus 0.3. So which is going to be 1.1 meter. The height of the center of mass above the ground is going to be 1.1 meter. Then below, at the bottom, it's going to be 0.2. So the change in height is going to be 1.1 minus, that means 1.1 minus 0.2, that is going to be 0.9 meter. Change in potential energy, that is mgh. Mg is already given, the weight as 500 Newton. Change in height, we already found 0.9. So the answer is 450 joule. As you can see, that is the option from C.